Good morning, everyone. Oh, you are awake. That's good. Welcome to the last day of this conference. I hope you had a great conference so far. And let's continue in that same spirit. I'm a bit surprised to see so many people. It's like admitting that you're writing buggy code. So come on. You know, I can tell you like that, the reason I'm doing that is because I have a friend that sometimes, writes some buggy code. So I'm trying just to see how can you help. I know your code is perfect like mine, and I know you all have friends, although we are introverts, but we still have some friends that might have some problems with their code, and we want to help them. That's what we are, helpers, aren't we? Okay, so hopefully it will be an interesting session, and at the end of the day, or at the end of this session, you will learn some new stuff. I want to warn you about one thing, because I'm doing a lot of stress testing of my application. There is a chance that my computer will crash. So that will leave me, talking for a couple of minutes until Windows will restart and try to do all the stuff. But just so you know, if that happens, actually it means that I succeeded in doing my job, because I stressed my application and I made it crash before it reached production. One might think that this is a production environment, it's not nice to crash in front of so many people, but let's see how we can do that. So, yeah, this is the name of the session. If you're looking for something different, it means you're in the wrong room. So, who am I? My name is Tiberiu Kovac, or Tiberius, as James Tiberius Kirk, or TB, the shorter version of it. I'm a software engineer. I worked over 20 years in this beautiful, area. Since 2004, I started to share my knowledge as a trainer. I'm a Microsoft certified trainer. I'm a IASA certified trainer. And after 15 years in Sweden and 1 year in Bermuda, I decided it's time for me to go back home. So since last year in August, I'm living in Romania. And I'm doing training and mentoring all over the world. So Romania is just, where I have my own pillow, not the hotel's pillows. Microsoft awarded me the MVP title in Windows Azure for all those contributions that I've done to the community. I'm a father. I have 2 daughters, 5 and 8 years old. And I'm a geek, of course. Otherwise, why would I be here? And you can find me on Twitter as Tibor19, and you can use the hashtag #MSTechEd. A little bit of history about this talk. Living in Sweden, I had actually the privilege of being colleague and close friend with Tess Ferrandes, and she was the goddess of debugging. I don't know how many of you have heard about Tess? Okay, only few, which is a shame. So 2 years ago, she left the debugging world just to start working as a developer evangelist, meaning trying to help other people to understand how Windows 8 works and trying to do some of the work. But her blog is still very active, in form of visits and people that are going and try to learn some new stuff. And she has even done a lab application that you can go and try some different things and see exactly what your application will behave. So some parts of my presentation actually are based on her work, on her lab. With her permission, of course, but I feel it's necessary to make it clear that some of the work is hers. And if you have any, questions or you wonder about something and you have some problems with ASP.NET, I think it will make much more sense if you go and look at that. So, how many of you work with ASP.NET web forms? Okay, so the most of you. MVC? Almost the same. So it means that people are working in both kinds of projects. And I assume that sometimes you might have some unexpected problems, and then you want to try to see what's happening. For today, I put together an agenda, and AKA my only slide. Here I have, some points that I want to reach, to talk about it while I'm doing this presentation. And we will look at some advanced options for breakpoints. When you create a breakpoint, F9, it's pretty nice. Everybody knows exactly where it is, so you can just press F9, or you can just click on the left-hand bar over there in your code window. But there are situations when you might need to do some more advanced stuff, not just sitting there and press F5. And I will show you some of those. And the reason I do that is because I was surprised to see that many people haven't seen that. They didn't know that a breakpoint actually have more than just an F9 to it. You can do some other stuff with it. Then we will look at some tools for debugging ASP.NET applications. We will talk about profiling ASP.NET applications, how you can do profiling of an ASP.NET application, and what's the reason you would like to do a profiling of your application. How you can do some load testing, because sometimes your application runs perfect on your machine, but when you run it in production, when you have 2 users instead of 1, then the application might behave a little bit erratic, and you want to see why is that. You want to make sure that something is, that you catch these kind of problems. And post-mortem debugging as well. If it happened that your application will crash, for instance, how would you go, and how would you go to try to find what happened with your application? Where would you go, and what are your options? So let's get started. And as I promised, this is my only slide. If you don't believe me, this is the demo, and then I have a thank you, or questions actually. So just to prove my point. Let's close that. So before we get started, let me show you some of my application, what the application does. Actually, yeah, the CSS, it's a bit wrong in IIS Express. I don't know why, although it should show, it looks fine in Internet Information Servers. So I have an application called Buggy Bits. I'm trying to sell some products, and I have some featured products, for instance, here. And if I go to run this application, something happened. It takes a little bit too long. I'm trying actually, or what we are trying to simulate here, it's a long-running operation. And we get some of the products we have here, how much would they cost, and how do you fix. For instance, you can buy a bug spray, so you don't need a debugger anymore. You can use it all over your code, and it will, the latest in this technology actually show that might improve the quality of the code. So you can try stuff like that. And I have another one, for instance, this review. The review one, it's creating a crash in the application. So if I press the refresh here, it will show me a new page, but in the same time, I will get actually something wrong. Of course, you're not supposed to use destructors. You're not supposed to do a lot of code. It's supposed to be safe code, but sometimes it's not. And of course, if you get if you get situations like that, the end result is that your IIS will disappear. Your W3WP .exe will disappear, and then you will get a new one. So mainly, this is the application we are using. So if we want to debug our application, of course, now I know where the problem is. So what can we do here? By the way, do you know that in .NET there are no data breakpoints? A data breakpoint, it means that you can actually monitor a piece of memory in your application, and then if something happens there, the processor will actually break your application, will put a breakpoint to your application over there. And the reason you don't have that is because the memory is managed in .NET Framework. And the way the data breakpoints work is they are monitoring a certain address in memory. When you do garbage collection, it's using something called mark and sweep, meaning that it marks all the data you are having in the memory of your in the memory of your .NET application that you are still using. It cleans everything else, and then it does a compacting, moving effectively the data. So if you don't have, by moving the data, you might change some memories, some memory location, but not because the data changed and because the garbage collection moved the data. So that's why you don't have any data breakpoints. It doesn't mean that you cannot monitor data. One way of doing it, for instance, is to add a property, and you just put a breakpoint on the setter, and then it will stop there all the time. So as I said earlier, the easiest way to add a breakpoint is just to press F9. By pressing F9, you get the breakpoint in that particular place. Or you can just go here and click with the left mouse, and you can change you can work with the breakpoint. If you have a breakpoint here and you right-click, now you can see that we get some extra options. For instance, we get an information about the location. It will tell us exactly in which file we are, at what line, and what character in that particular line, meaning where exactly do we want to have this particular breakpoint. Another point here is condition. If I want to stay here, let's say that it's not always it's crashing, but sometimes my application crashes. And I want to know when that happened. What I can do before it is too late, I can say something like that. If quote equals null. Yeah? So if quote is null, I want you to stop here. So I can go back to my application. I can run it again. Actually, let me close that and go to debug mode. So if I run the application again, and if I go to reviews, I can press refresh now. And before my application crashed, I got a chance to come here. And then I can look at it and see what's happening. I can look on the call stack, although I won't see too much on the call stack. Why? Who calls the destructor? Or the finalizer method? The finalizer thread. So the way these things work is that when you have a destructor or a finalizer in one of your classes, .NET Framework will, when it runs the garbage collection, will take the object from the memory, but will still keep it, or actually will take the object from the list of objects that you can reach, but will still keep it in a queue called the finalizer queue. The finalizer queue contains references to objects that are no longer needed. So when you get that, when you have an object there and it's not used anymore by your application, on the next garbage collection, the object will be removed because it needs first to call its destructor. So my finalizer thread, actually, it's called from the native code. It shows me here. Yeah. And then it will run my destructor. So if I have a problem here, the way .NET it's running is that if you have an unhandled exception in a thread in your process, it will just kill your process. And if you have configured, for instance, on your machine that you want a crash dump, it will put a dump of the, it will just take a picture of the memory of your application and will write it down on the disk. By doing that, giving you a chance to do the post-mortem debugging of your application. Okay, so now I see where the problem is. Of course, I can go and fix it, but that's not the point. I don't want to fix the problem. I just say, okay, you know what? I want you to move from here to another line. Let's move to the last line of this code. And we are just avoiding calling the destructor. Of course, I have another object. I will have exactly the same situation. It will call again the destructor. So now I have a chance actually to see what's happening. Okay? So, how do you do when you have a production system then with this kind of situation? Because it might crash on you, and now we have a breakpoint, now we can fix that, but if you have something in production, how would you do that? Well, the easiest way actually is to just go and look in the event viewer. Let's do like this, control panel. All control panel items. So if I go and look into event viewer, I can actually take my log, look into my application and see what's happening. Let me remove that. Let me clear it so we can see a clean log. And I can go now. I have the same application deployed actually on my local IIS machine. And I use the buggy bits as a name for it. Okay, so now I do the same thing. I do the review. I press refresh. IIS is pretty smart actually. It does understand that something happened, and what we'll try, if one request is crashing, we'll try to play it again. So if one of my processes disappeared, it didn't get any answer, it will just do the same request again, and then that's why I get an answer. By doing that, what's happening? My object that had a destructor was in another process. So it just got destroyed, or it just got a crash on that other process, not on my current process. So if we go now and look at the event viewer, and we do a refresh, we can see information about what's happening in my application. We can see the errors here. We can see that the error was actually null reference exception. It gives me even the information which object it was. And I can use that kind of information actually in order for me to try to localize what was happening in the application itself. It tells me what the .NET runtime was doing, what was the stack trace. Remember, before that, when we looked in Visual Studio, we had exactly the same kind of information saying to us that we had a native to manage transition. So it means that the first method we will see would be that one. It's what the finalizer thread is calling. And then we have some application error information telling us exactly what was happening. And then the Windows error reporting. So the Windows error reporting system, it tells us that there was a problem. So we get same kind of information in several ways. And just so I can show you, I can show you that we start to do a garbage collection process on this process, or garbage collection on the process, and I can show you where this information comes from. So if I go to the reviews and I look at my implementation, the refresh button, it does actually write into the garbage collection, into the event log. In Windows event log, it writes the fact that actually we are doing a GC, and when we are done with the GC, it shows us that we are working on that. The application, it's still not, if you think about it, the application, it still didn't have a chance to crash, so that's why you get to see both of those messages, but the request that it gets served next time would be from a new process, because this one was dead already. So let me go back and just show you this. So the next time it comes and it says, sorry, we are doing that in another process because the previous process died. And this is the previous process. What is the number? Come on. Yeah, 4720. This one? Yeah, it's the same, 4720. So if I go back now and I would say I don't want to do a refresh, you will see that I get 56 as a process that crashes. Let's do a refresh. Yeah, it's not working anymore. So let's try reviews, refresh, and if we go now here and do a refresh as well, we can see that we have a new process ID. It can be 4720 again, because yeah, 6656. You see, this is the one that crashed next time. So when you trigger a garbage collection, it will trigger the garbage collection and it will try to clean up the memory, and it realizes that, okay, I can't finish that because some of the problems that may appear, and then it's redoing the request, so then you still get the information out. Another thing you can do with breakpoints, actually, if I don't know exactly where a breakpoint is, or I don't really have the method, I don't really have the source code for the file, but I really want to stop. For instance, I know that I do some formatting, or I know some concatenation on the strings. I can go here, debug, new breakpoint, and I can say breakpoint.function. So I can specify the function name, or I can just say something like this, system.string.format. If I press OK, it will tell me, sorry, I can't find it that with the IntelliSense because it's not in my file, it's not part of my code. But if we look here now, debug, Windows breakpoints, we can see that we have a string.format here. So if I run the application again, it might stop beforehand because .NET Framework might have its own system, string.format calls. Let's see. And hopefully it doesn't take too long. Okay. It's running. It's running. Is it? Yep. Come on. Oh. So let me see. Yeah, you see? So diagnostic file version, get version, string info, string.format, and so on and so on and so on. So it will stay always here, and it will take a while for me until all the .NET calls are finished with doing that kind of stuff. So what I can do instead, it's actually to put a filter on it and say, you know what, I don't want you to stay always. I just want you to stay when it's in a particular thread. Or if the, let me see, where is it here? Breakpoints. Debug, Windows, breakpoints. So we have this, and we have a lot of formats, and we have a lot of overloads. So let's close that, and let's keep only those that we know we will use. I don't think it's only that. In two places. String.format with this kind of signature, it's used only in two places, so everything else is disabled. I can say continue. Then the application will continue, and if I go to the review and press refresh, now it will stop in my code. I can go and say call stack and see exactly where I called string.format. Sometimes it's very important. For instance, if you don't get too much information, if you don't have the PDB files for your application, but you have the name of the method, you know exactly which method crashed, you can take it, you can copy that method, you can just add it in your you can just add it as a breakpoint in your application, and then when you run it inside Visual Studio, of course you'll have no problem, and you can see exactly what is happening and what went wrong, or at least you get a chance to stop before something happened. If I couldn't have done that, the only chance I would have had, it was just to find myself inside the debugger after the crash was happening without knowing exactly how I got there. In that case, when I put a breakpoint before that, I get a chance to see exactly how did I get there. Another way of working with breakpoints, let's stop this and go back to the breakpoints window. I can actually remove that. I can remove that too, is that I can go here and say hit count. So let's say I don't want you to stop first time. I know that if I run that 10,000 times, the 10,001 time after I run the application, I will get this error. So I want to stop, I just want to let the application running for a while and do all the stuff that it has to do, and then when it comes to this point, it will stay, and I can do debugging there as well. So I can say when equals to 100, or I can do it like when it's a multiple of, like every 10th time when I run my application, I can see that something wrong could happen here. So what I do instead, I said, okay, every 10th time you have to start here and to stop here and do this functionality. Or after 10,000 times, I want you to stop every single time because I really need to know what's happening here. Okay? Another way is the filter. I mentioned a little bit earlier that you can set a filter, and the filter actually could be based on the process ID, could be based on the thread ID, or even the thread name. So I can write something like the thread name equals main thread. Main thread, assuming that we have a main thread. So whenever a crash happens, when a crash happens in the main thread, I want you to stop, or whenever you reach the breakpoint actually in the main thread, I want you to stop there. And if you think about multi-threaded application, when you have 10 threads doing the same kind of thing, maybe calling the same method, but you know that only one particular thread is the one that may cause your crash, it's a very powerful tool that you can use in your application. If you do remote debugging, you can use as well the machine name. So you might be attached to several processes at the same time. You want to filter only on that particular process because you might have the same library loaded in different processes on your machine. Another one is when hit. When hit, it's actually called a trace point, meaning that it gives us a chance to write a message to the console. So I can say print a message, and what should the message be? Okay, when you come to this one, I can say we are in the function, whatever the name has, and this is the thread ID, thread name, and I can look, for instance, at this pointer and get information about exactly what's in the current object printed to my output window. There is one thing here. If I run this application like that now, let me show you. So I have a breakpoint here, and I have a when hit condition. And if I run now my Internet Explorer and I try to go back and run these reviews, and press refresh, it never stopped there. But if we look here in the output window, we will see that we got the function buggy bits, review, thread, and the object that I was using. The object was an ASP, ASP.review.aspx object. So I got the information, but it never stopped. And the reason it never stopped is because when you use trace points, I don't know if you noticed, there was one checkbox there and says continue execution. Continue execution, it means that always it will just, instead of stopping here, it will continue. It will print a message and it will continue. If you want it to stop, if you have some conditions that you want to stop there as well, not only to write the messages to the console, you will have to do it like that. Remove the continue execution flag, and then it will do that. Okay? So let's see. And last but not least, you can actually add labels to your breakpoints, and by having a label and you can do some descriptions, other people can actually understand what's happening. You can even have actually, when you run your application, you can have data points in your application. So a breakpoint can have some information, and when you look at the particular information, you can export it as an XML. You can give it to one of your colleagues. So I can go here and I can pinpoint this one. I have the message now pinpointed. I can run it, and I have some information. I can add some comment to it. Come on. I can add some comment, and I would say this is what is happening in refresh. So by having that, then I can go and export that, and I can even pin it here. It's already pinned, actually. I can export that, and I can send it to one of my colleagues, and he can actually import all those breakpoints, and he can reproduce my problem exactly, and go there and see my comments and see what I was thinking about it, and maybe even put his own comments in there and send it back to me, and so on. So it's a very powerful tool if you want to do debugging inside Visual Studio. So let's continue. And again, we crash in this because we never got a chance to fix the problem over there. Okay. In Visual Studio 2010, Microsoft added something, or actually the Microsoft Research had a tool called Debugger Canvas. How many of you have seen that? Very few, one person, I think, which was a very powerful tool. You can see the code in a different way. You can see the code actually, the relation between different methods. You could see how the different methods were actually working with calling each other, and you could see which threads were calling that particular method. And you could have a very nice way, you know, every thread was having actually a different window with all the variables and all the call stack, and you could see it side by side with different colors, which made it a very powerful tool for debugging. For some reason, they did not update it yet to Visual Studio 2012, although the latest update for 2010 came like 3 months ago or something. So they are still working on it. Maybe they are not yet ready with that one. So just as a pointer. And by the way, whatever I'm doing here, it's working as well in 2010. So it's nothing that it's particular specific to 2012. So just so you know, if you go home and if you are not running yet Visual Studio 2012 and waiting for 2013, then this is a very good starting point. Okay, so that's about it when we talk about those kind of breakpoints. Now let's do something different. Let's start to see how can we debug our web front, you know, our front-end application. So we have different solutions. One of them being actually using the Page Inspector. How many of you have used Page Inspector? Okay, around 20% maybe. So the Page Inspector is a mini web browser that is fully integrated inside Visual Studio. And what you get with it is as soon as you go and try to browse to a specific part of your page, it will show you exactly who is responsible for rendering that particular part of your page. Come on. Where is it? Oh, it's still loading, of course. Come on. It's a little bit busy for some reason. Let's give it 5 more seconds. If not, I will have to kill it and, yeah. Come on. Let's do that. Okay. Yep. Let's start it again. I told you that would happen, so. And now, of course, it's up. So, let's see. Do I have something running on my machine that... No. Except Visual Studio? No. Then why it's so slow? Come on. Solution Explorer. Let's go back and try again. View, in-page inspector. So now it will try to run the application, and it will show me exactly all the elements. So I can go here. I can do some inspection. Come on. I can inspect the elements here. And it will show me, wait, come on. It's still refreshing the screen. Inspect. Am I pressing the wrong button? No? Come on. It's very, very slow for some reason. And nah, I don't want to do that yet. So let's go back home. It's loading. Show me all the files. Come on. Inspect. No. Let me try and see. Task manager. Nothing else is taking power of my machine, so why would that happen then? I think it's a refresh problem. I don't think it's a problem with Visual Studio as it is with the refresh of the screen. Come on. No. I'll close it. Can't even, no. Oh, I don't think, yeah, you're right. Oh, yep. All the system.strings, yeah. Actually string format, but I removed them. Debug. Come on. It's, oh. Okay. So. It's still, come on. So, debug, Windows. Oh, it's here. No, breakpoints. Actually, it's an easy way of doing that. It's not. Control-Shift F9. It should ask me, are you sure you want to remove all the breakpoints? Control-Shift F9. Come on. No. I managed to kill the machine. Let me... So, debug. Delete all breakpoints. Yes. About now. Is that okay? Still not. No. I need to start it again. Yes. So I pressed the Control-Shift F9 and it started Camtasia. Come on. Now. And now I will get again the page inspector window. And I can close it. Can I? Like this. And then open the buggy bits. Let's see. Bug. So there are no breakpoints anymore. We can just open the window, the breakpoints window, and look, it's okay. Let's try one more time, and if it doesn't come up pretty quick, or let's take the default ISPX because it's a simple page, viewing page inspector. Dum, dum, dum. So. Nope. It's not really. It doesn't want to cooperate. When you don't do stuff like that, it usually works. So I managed to put the machine in an unstable state. Let's see. Let's see other options. One other option is actually Chrome or F12 in Visual Studio, but I think Chrome is much better at doing that. Let's remove this. Let's reopen the buggy bits. So with Chrome, you have the developer tools as well, and you can open a page, for instance. Let me get here. I can actually choose what browser I want when I debug my application, and I can see exactly how it looks in different situations. It's a very powerful, especially when you want to see why some of the stuff that you have on the client side, like JavaScript, or some of the styles are not aligned, and some of the colors are not the way they should be. You can use this one, and you get a lot of information. The same actually is available with the page inspector, and the page inspector is using both the client and the server side. So if you have something like an ASPX, or you have a Razor page, for instance, in MVC, it will show you those as well. So you get the whole story. Here you'll get only the client-side story. You don't have the connection directly to the server side, but I think it's still a good tool for you to be able to understand why your application looks like it does. So here, by the way, another application that you can use, it's Firebug. How many of you have used Firebug? Okay, so I think that was the inspiration for all the F12 tools, for all the Chrome functionality that you might see in your application, and you just install it from here. You can activate it in your application, so you get the information. You can look at localhost. Let's take actually the buggy bits. Okay. And now you can see what's happening. You can actually do an inspect, and you can choose what element you want to inspect. You can see all the styles and all the information. And it will help you understand what's happening. Another important functionality here is the network. You can enable that, and then you can see all the traffic. Most of the problems you will see when you have a bad performance in your application are actually coming from the client side, are actually coming not necessarily from the implementation of the client side, but from the way you are communicating with the server. So you lose a lot of time, for instance, on the latency of the network. You lose a lot of time to download all the JavaScript file and all the styles and all the images that you have. So although, looking on the server side will be a very good way to start because there at least you have control. When you do a performance analysis of your application, I think it's much, or I recommend to do an end-to-end analysis and to look exactly from start to beginning, how long it took, for instance, to initiate the request, and how long it took to get back the first bit from the server, and so on. And when you do this kind of profiling, again, it is shown that in most applications, like 80% of the application, the problem is not within the server, it's in the client. So now, depending on how you want to pursue this kind of situation, you have different choices. There is a book called actually Faster Websites, I think it's called, and the Faster Websites application. The book, it gives you 10 practical tips on how you should set up your web application in order to be able to get the information that you need. Next on our agenda would be to look at some of the performance analysis of your application. So one way to do that, we can take an application, for instance, we can do some analysis here, and we can start a performance analysis. Is it running? Let's stop it. Stop debugging. So when you go and try to do an analysis, you can say start performance analysis or start performance analysis post. If I want to start it directly, I will just choose that, and it will create a new session, and my application is now running, and it takes me to the default page, and then I can click around, I can see what's happening. For instance, I'll take this featured product, and I'll run it a couple of times just to see what is happening. So mainly in this application, what I have a very simple method. It's trying to read some data, and before it reads the data, it does a thread wait for 5 seconds. So when I'm done with my profiling, this is a very simple profiling of an application. I can close that down and close all tabs. And when I do that, it will gather all the information, and it will try actually to show me what my application was doing. Oh, it's still profiling. Yeah. The reason it's still profiling is because Google Chrome doesn't work pretty nice with the. It doesn't work very nice together with the. Come on. With this start profiling. Let's start again. It doesn't work pretty nice with Visual Studio. So whenever you do something in there and you close the application, Visual Studio does not realize that the Google Chrome is closed, and it's still hanging on the debugging session. So let's do that again. Opening new tab, opening new tab. So we get some functionality here. And it will take around 5 seconds per page to load. This is done. Now it's this done. And now we have it. So let's close this one. When you close this one, or exit the application to generate a report. And now it's generating the analysis. When you talk about profiling of applications, there are two kind of profiling of the application. One of them, it's called snapshot or snap profiling. What does it mean? At a certain period of time, the application, the profiler will just stop your application, will look at whatever it's doing, which method is it running, and then it will say, okay, I can see that you are running this particular method. And it increments a particular counter. And it has another counter with all the call stack, and it will increment that as well. So you have something called inclusive sampling and exclusive sampling. So it takes snaps of your application or samples of your application and just try to build up this number. The other way of doing it is actually instrumentation, meaning that every single time you call a method, it will just say, this method now has started to run, and then when you're done with the method, it will say, this method has finished running. And then you can see exactly how long it took every single method to run. And then at the end of the profiling, you'll get a much better information. There is a bigger advantage to have this kind of instrumentation, but the problem with that is it's very intrusive. your application will run much slower. So you won't afford to do that in production. You might do it on your own machine. You can try it and see exactly what's happening. And then when you have this information, when you have this information, then you can go exactly and try to pinpoint the problem. And this profiler in Visual Studio saved me actually twice. In two different situations, we had a very big problem with our application. And I was trying to figure out what's happening. And just like going on the code and try to see which page is the one that is creating a problem, it's not really the way to go. So the way I solved it was to start the profiling session and running the application, do some load testing on the application, and then when everything was done, I could look on the call graph and see exactly which method was the method with most problematic, or at least the one that took the most time in my application. And it takes a little bit of a time to set up and to understand exactly where the problem comes from, but when you're finally done with it, you can actually see exactly where exactly the problem initiated from. And once was actually some poorly written data binding. So the way someone was doing was, reading the data on the raw data bound, for instance, in a grid view, and you don't realize that something could be wrong if you run and you have only 2 answers or only 3 answers. But when you get a list of, 1,000 products or whatever you want to put in your list, and you want to show it on the screen, then for every single row you call the database, then you will have a problem. And the only way for me to discover that this was a problem was actually to do the profiling and see exactly what was happening. Especially that I wasn't part of the development team. They just they called me only when it was, too late. It was in production, and they realized that at a certain situation or certain points in time, it takes a long time to do some certain stuff, like loading a page, a simple page. Even the first page of the application was not responsive as it should. If you wonder what's happening here, it's downloading actually some of the symbols, the PDB files from the Microsoft symbol server. So if you want to get information about, about the line code where something goes wrong in your application, you can go in Tools, Options, and then you have debugging, and on the debugging window you have the possibility to set the symbol server. If you are using WinDBG, for instance, you have to set an environment called _nt_symbol_path. And when you set that, you would say, okay, I want you to look in those for those particular sites to find where the information or where the file line information resides. If you don't want to wait all the time like this, although I don't know why it took so long this time, because I did actually a local cache, you can choose to save locally all those PDB files. So I chose this folder, and I have it on my machine. I actually have a folder now called C cache, symbol cache, like this. And there are a lot of DLLs or a lot of PDB files downloaded from Microsoft site here on this folder, so I can actually look at what happened. It is recommended that you use the symbol server as well in your production, and every single time you do a release, you save those PDB files. The PDB files, even if you run them, for instance, for release mode, it doesn't affect the performance of your application. You can still include debug information in your application. The only difference would be that everything that is marked with debug, it shouldn't be there, and everything that is actually in everything that you have in your application, it's marked for optimization. So now you'll get a better code, you'll get optimized code for the production, but you still get line code information in those PDB files. And then if you want, you can configure a symbol server, and with the help of the symbol server, you can get this information. You can as well configure a source server. By configuring a source server, you can actually get the source code of the files. Microsoft has, for most of the libraries, has actually given us access to the source code files. And having access to them, it means that it will go to their public server, it will download the source code, and we can see exactly how the code was running and what was wrong and what did generate that particular problem in our situation. When you run your debugging, you can actually enable just my code. By saying enable just my code, it means I don't want to go and look at at whatever .NET framework has to show. But actually, usually that is a very important, quite often it's an important information. Enable just my code is when you don't do normal debugging, you just do development and you don't want to take it a very long time to load and you don't want to get all the symbols loaded when you do the debugging. So it will speed up actually the F5 process. And source server support, I can get all the information. I can allow partial trusted files, for instance. If someone builds a third-party library and it configures a source server for that, I can get the code files for Hibernate, for instance, so I can use those as well. So here now I get some information about my application. And I have a summary. I have a call tree. I can see exactly, oh, it's all in Internet Explorer. And ES Express, it shows me exactly what's happening. I'm running the application in IIS Express. I can press in this one, and it will show me this one. It will show me actually which is the hot path. What exactly takes longer than normal, and what exactly do I need to look for in case to solve, that I need to solve my problem. So I can expand this, and I have a process request method. That process request is actually part of the system.web, so it's not my code. If I want to see exactly what's happening in this code, I can double-click here. Come on. Why don't you take me to the file? System. Okay. So, featured product ASPX and default ASPX, those are the stuff that takes longest when I run the application. And I can go into the featured products, but something is missing here. I don't think it loaded all the symbols, and because of that, it can't take me to the line of code that this happened. So it doesn't have the full symbols for that. But normally when you get those symbols, you can just double-click here and it will take you to the line code, so you can actually follow the whole chain, the whole call chain, and understand what was wrong with the application and how you can get to this point. But this is only when you do small tests, and you want to run one simple application, or when you want to do something like click there and do that and do that. But how should we do if we want to have a more, more information about what's happening? One way would be to run something like TinyGet. I can just download TinyGet and say, you know what, I want you to run 2,000 times with 50 threads, just load my application. It's not really integrated, it's not really doing a lot of work, but it's still a possibility. Another way of doing it is actually to use web test performance and load performance of your application. So let's do like this. I can create a new project. The project type would be test, and if you go in test, you can find web performance and load test project. Buggy bits. Okay. Oh, dot load, I wanted to call it. Like that. Okay. Let's say web test. Like this. So when I create that, yes, I want to replace that. It will just create the web test. The web test is a simple page. Let me do like this. That I can use to try to load my application. Control-C. And I can say, okay, I want you to record some of the stuff that I might do when I go into my application. And I want you to remember those. So the recording has started. Now I press this. And after that, I go and press feature product. So now I have a complete session. So that's a scenario when my user are normally taking. Press that and then go that and load that file and see the results. I can say stop. It will try to use some parameters and see if I send any parameters or anything and try to make them dynamics. If I want to automate all those tests as well. It will show me the result of the test. And then when this is done, I can just run it again in my application and see exactly how it will behave. So if I want to see how it works, I just go here and say run test. I run the test again. and it shows me what it does. It goes to that page, it says 200 OK, and now it's submitting to the next one, and the total time was 5 seconds. And it's OK because when I recorded it took us long, so it knows exactly that this is something that is a normal behavior. Now with the web test, I can go in and say, add new load test. Add new load test. So a load test actually will simulate a load into my application. Now, to run that in the same machine, like I do my development and like I run my application, might not be the best solution because I will load both by sending the request. I would load both by replying to the request. It's like playing, field tennis with myself and being on both sides of the, on the field, which is not always very pleasant. So let's call that this web test 1 scenario. Yeah, so that's what we decided first time to call this one. How do I want to do it? Should I record how long it takes to think, or if I want to do a normal distribution, if I want to run it always, or just wait 1 second in between test iterations? 0 is OK. How do I want to do the load pattern? By default, you have 250 users, but you can actually enable more. There is a hack somewhere that you can use it, and you can run actually more than that. So let's take 250 users. How do I want to do the mixing of the test? Do I want to use, based on the total number of tests, or do I want to use only a certain amount of virtual users, or some users are slower, some users are quicker? How do I want to mix that? If I have several web tests, I can add them, but in my case, I have only one, so I just add this one. But if I have several, I can add all of them. I can say, I have users coming from all the directions doing all kind of stuff. So I have the possibility to do all those choices. Where my users are coming from, is it LAN? Is my grandmother coming with a, with a 56K modem, or someone who exactly is the one running my application? LAN is fine for this situation. It doesn't matter. As well, the browsers. You can go and choose pick and choose whatever browser you have. From 5.5 again. If grandma is around, she can do some testing, or I can at least simulate how the application will run in her situation. Yeah. I can say what counters do I want to use. If I want to use some extra counters, not only the ones defined by default, and some settings. How often do I want to take samples? Of course, I don't want to take samples too often. 5 seconds, actually, it's the lowest time that you are allowed to take samples when you do load testing. If you want to do it longer, you can do it longer. And run duration, it should be 1 minute, not more than that. Warm-up duration, now depending on the kind of application, and ASP.NET application might be enough with 1 minute. A SharePoint might need 10 minutes, but it's, it's depending on the configuration you have. You need to warm up just because you want to avoid all kind of stuff that might happen, might not be there, or you don't want to have the hits or lower performance shown here just because your application needed to be compiled and some other stuff were not started. So normally you do a warm up. I won't do that. I just use 1 minute here, and I will try to run the application to create the test, and I can go here now and say run load test. When I run the load test, come on. It will show me the result. Like this, I can see the page response time. I can see exactly how I want one panel, and I look at the page response time, for instance, and I want to see how long it takes for each page to respond. So the first one was actually 0.87. Now it's 5 seconds, and we will see some interesting results: 7 seconds and 9 seconds, and so on. The reason we have that problem is because every page has a thread wait for 5 seconds, and it has a synchronization object, so I create a carambole effect, so everybody's waiting for everybody in order to do the kind of thing. It's not, that's not something you should see in your production system. But I just want to show you that based on that, actually, by doing some load testing of my application, I can get some information about how these two relates to each other. I won't show you how, but I can tell you that it's possible, actually, to combine the load testing with the performance analysis. So in order for me to do a truthful performance analysis, I can actually look at, I can create a load test for my application, and then run the load test while the performance analysis is running. And by doing that, I have a chance to have a lot of users. I have a chance to get a lot of information about whatever was happening. So it shows me the slowest tests were 56 seconds. So one page that I was trying to run, because I said 250 users. When I try to run all those 250 users having the lock there, I won't actually allow more than one user at a time to see my application. I can go back and change the code if I want to, just to make sure that is running a little bit quicker. But it still doesn't. And we will still see exactly the same kind of information. So I will put in together with the code that I'm showing here, I will zip it together, and I'll put a list with the links, including the link where you can get the blog post that you can get how to do the web performance and the load test together, because you would need to manually run the test runner for loading, and then configure that one together with your performance analysis in order to do all this functionality. One thing that it's missing in Windows 8 is actually the symbols for all your .NET libraries that are engined. So NGen is a tool that comes with .NET Framework, and it takes all the .NET libraries and compiles them so you have a native image, meaning that it has the real binary format. The reason you want to do that, or the reason Windows is doing that, it's because it needs to know exactly on which machine is running, what kind of features you have available on your processor, and by doing that, it will speed up the process of loading a new .NET application when you run it. So that's why it's very important, for instance, to do the NGen if you want the higher performance on your application. The disadvantage with that is that you won't get the NGen, you won't get the symbol files, the PDB files for that. So in order to solve this problem, what you would have to do is to run NGen again, and NGen has actually one switch called create PDB. So create PDB, you would say where is the DLL file that you want to use to create the PDB for, and then where exactly do you want to store the PDB file. So normally you would store it in your cache server, exactly the one that I had, the symbol cache folder that I had before, because Visual Studio will look there. If I configure my WinDBG will look in the same folder. So I need to do that in order for me to be able to have all the symbols loaded as well for this, because it's local on my machine, then they are compiled to be native applications. Okay. Last but not least, I want to talk about the post-mortem debugging. And post-mortem debugging can be done in two different ways. So one way is to automatically have the application, for instance, from time to time, to have the application when it crashed to generate a dump file. And when it generates a dump file, normally it's under current user. So for instance, if I run an application and it crashes while I run it, I can go in my C users, Tiberio, up data, local, and then I have a crash dumps folder. So here I can see all the crash dumps that were taken by the system. For instance, the Evernote application crashed, Internet Explorer crashed a couple of times. So I can go and open those files actually with Visual Studio, and if I have access to the symbol files, I can see exactly what's happening. So let me go here and look at processes. And we need to find the W3WP. I don't know where it is. I will just do like this. I will take whatever application we have in here. For instance, this one. I can take Dropbox and say create dump file. When I create a dump file, it will just stop my application, It will look at all the memory, it will take a picture of the memory and save it to the disk. And it will tell me exactly, oh, by the way, we saved it in that folder, so you have it there. Now, the problem is that when you are in production, you don't have access to this. You don't go there and you don't log in you do not log in on the machine, and then you look and say, okay, I want to look at the task manager, I want to find process X, and then I want to do a memory dump. So how do you do then? Well, the easiest way would be actually to run a command called AD+. AD+, it's part of the debugging tools for Windows. Let me show you where AD+. So it's installed on the the C program files, Windows 8 debuggers x46 AD+. So I can run AD+, and I can say like that, I want to do in a hang mode. Hang mode, it doesn't mean that it will hang the application. It will just stop the application while it takes it takes a picture of the memory and how the memory is done. I can specify the process name, and the process name is w3wp.exe. And I can specify minus quiet, for instance, like this. And it needs an output folder dot minus o, and I will take c/dump files minus quiet. Some selected processes are not running. So W3WP is not running anymore because I haven't done anything. It's not there. Retry. Let's see. Maybe I should go to home. Let's try again. Now it's there. And it will create in my dump files folder, it will create a folder which is the current date and time. Actually, yeah, that's the Romanian time, and how it was taken as a hang mode. And then if I go in there, I will say exactly what was happening. Let's try to do that again, but this time I will do it on the featured product, when I know it takes a little bit longer. So I will do it again, and it's 73720 hang mode. Let's go there and see dump files, this one. And here I have information about the dump file, and it gives me some information how you can run a dump script, debugger script, and what you can do with it. Another way of running, this is only looking at W3WP process. If you don't want to do only that, you want to do all the IIS related processes, you can just say -IIS. And it will know by default that it has to look either at W3WP or ASP.NET _WP.exe, depending on what version of IIS you're running on your machine. So when it creates this file, you can go in and see that actually we got some more log files in here. We got init info and we got W3WP because those are related actually to that. Now because we have that, I can go in here and say File, Open, File, and we can go here, see, Dump Files, and I can open the file actually in Visual Studio. So if I have a problem in production, I will just have the script ready there. I will just run the script, and then I will ask the admin, please run that script for me on the machine. And then when you have the script, send it to me so I can actually analyze it. Opening the script, it's straightforward. You just do like that, and it will tell you, okay, let's start debugging. Actually, it's improper to say that we want to start the debugging process because we don't have we can't go further. The only thing we can go is just to look backward into our application. So it's still loading some symbols. They should be on my local machine. It shouldn't take that long. So I think my machine is still hurt from that previous crash. So anyway, when you have all the symbols and when you will get the possibility to look at the information and see exactly what your application was doing. That can help you a lot, but it's not really not in all the situations. So another option cannot be found. Yeah, it should be actually possible to find those. But if we look at the call stack, come on. we should see which methods we have. Of course, break, and it doesn't show us the code because it doesn't find the symbols for w3wp.exe. Sorry. So normally when you have that, then it will be able to show you as well the native code, the managed code, not only the native code. We can look at the modules that are loaded and where are the symbol files, and it will show you all the symbols files. This one couldn't be found for some reason. System.web.webpages deployment, but is not needed. This one is not needed. This one is not found for my particular page. Strange. Because I configured to have the same, to have the symbol files for that as well. Anyway, if you get all those files, then it would be possible for you to just go to the code and see what was happening and why it took so long, for instance. So when you have this kind of situation, run the AD plus, and you would have information about your application. There is a thread window as well, so you can see which threads were running. Let's see, threads like this. Come on. And it shows you all the threads that you have in your application. So you can switch to different threads, and then you can try to understand what's happening with those threads. There are two versions of AD+. There is a 32-bit version and 64-bit version. So if you're still running some 32-bit application, you can look at them. Okay? So we were here. Come on. Like this. So we were looking at some of the advanced options for the breakpoints. We talked about some of the tools for ASP.NET applications like Firebug, like Chrome, like F12 in Internet Explorer, Page Inspector, if it does work, profiling. We looked at the profiling in ASP.NET applications. We talked about some of the load testing, and as I said, you can combine the two of them. It's not as easy as 1, 2, 3, but it's a little bit of work. But doing that, it will help you actually do a very good profiling of your application, and some post-mortem debugging, how you can generate dump files, how you can load them in Visual Studio, and that will help you actually to understand what's happening with your application. So we have 3 minutes for questions, if you have any. Maybe you can go closer to the mic and ask the questions. Okay? No? Otherwise, you can come here and, you can ask them here. I would be in the Ask the Experts booth for the next 2 hours. Yep. Thank you.